Hello viewers, in today's class we are going to discuss yet another important and very conceptual problem from definite integrals involving signum function, right? So here we have a very interesting problem. We have to find the value of this integral, that is 0 to pi, and we have signum of tangent of x, right? So let us start. So let us first call this integral as I, right? And here what we will do, let us first see the definition of signum function, right? So signum of y is defined like this, right? Signum of y takes the value plus 1 whenever y is greater than 0, and signum of y is 0 when y is 0, and signum of y takes the value minus 1 whenever y is less than 0, right? So let us now apply this property or this definition to signum of 10x, right? Signum of 10x. So here let us quickly revise some sign conventions from trigonometry. Now from trigonometry, we know that suppose here we have the quadrants. This is 0, this is pi by 2, this is pi, this is 3 pi by 2, and this is 2 pi, right? So these are the four quadrants: first, second, third, and fourth, right? And we know that the tangent of x, that is 10x, is positive in the first quadrant, right? And tangent function is negative in the second quadrant, right? So here we'll restrict ourselves to 0 to pi, right? Okay, so now what we will do here, we'll break this integral as a sum of two integrals, right? So I can be written as 0 to pi by 2, and we have a signum of tan x dx, and then we can write pi by 2 to pi signum of tan x, right? So now see, in the first quadrant, that is when x belongs to the interval 0 to pi by 2, tan x is positive, right? So this takes the value positive. So here we have tan x positive, and we can write it like this. This is a positive quantity here inside this signum function. So whenever we have here the positive quantity, that is y is greater than 0. So y means here the positive y, right? So for all positive y, signum of y takes the value plus 1. So tan x is positive in this interval 0 to pi by 2. So here signum of tan x will take the value plus 1 when x belongs to 0 to pi by 2, right? Okay, now when we go from pi by 2 to pi, right? So when we go from pi by 2 to pi, it means we are in the second quadrant, right? And from trigonometry we know that tan x is a negative quantity, right? So when here we have tan x negative, then from the definition of signum function we see that for negative y, signum of y takes the value minus 1, right? So here we have minus 1. So here x belongs to 0 to pi by 2, and here x belongs to pi by 2 to pi, right? So now here we can write signum of tan x as positive 1, 0 to pi by 2. Here we have plus 1, and here we have negative 1, right? So when we go from pi by 2 to pi, here we have negative 1 dx, right? So now we have the two simple integrals. So we can have x here 0 to pi by 2, then we have here we can take this negative sign outside the integral. We have x and pi by 2 to pi, right? So this is pi by 2 minus 0. We'll substitute the limits here and we'll take the difference. and here we have pi minus pi by 2, right? So this is pi by 2 and this is also pi by 2, so this is equal to 0, right? So the value of this integral is equal to 0.